Hey guys, how's it going? Thanks for coming out. I know it's pretty rainy outside. Today we're going to be talking to you guys about DevOps and QA and how it's operated in our studio at KIXEYE Australia. Hopefully the information we tell you today will be interesting or you'll be able to apply it into your own projects. But while we're doing it, we're going to be pretty brief so we can go through everything. If you have any questions at all, just wait to the end and we'll be happy to take any. Just to start off, my name is Mara, and I actually studied here at QUT, did a Bachelor of Games in Interactive Entertainment, and I've worked at KIXEYE now for about a year and a half. I work in quality assurance, which means I'm doing feature testing, integration testing, and I also manage one of our external teams. Over the course of a sprint, I'll usually be working with devs during the development, deployment, and release phases of our sprint. And next up is Bec.
My intro can luckily, I am not Karen.
Sorry.
It's okay. My intro can luckily be pretty brief because I can just piggyback off Mara's. I'm also QA, so I do the same kind of things throughout a sprint. However, instead of working with a QA team, I work with our localization team that's 11 people strong because we're localized in 12 different languages, and I work with them every week.
Thanks, Bec. Hi, I'm Karen. I'm a DevOps engineer at KIXEYE. I'm actually relatively new to the gaming industry. Click. What? And previously I've worked in multiple industries and sectors, and currently at KIXEYE I work on the cloud infrastructure, the processes for build, deploy and release, provisioning, development, monitoring and maintenance. So today we're going to give a brief overview of how we support a live MMORTS game. So that's what Vague Conflict is. It's a game that's set in space and currently running cross-platform and across web, Steam, Android, iOS, as well as being localised across 12 languages. The studio itself for KIXEYE Australia is based in Brisbane. It's made up of approximately 40 people of different disciplines. The game itself started as a Facebook game written in Adobe Flash with the working title of Galactic Pirates. It was launched on Facebook and KIXEYE Live, or KIXEYE.com, and was hosted originally in Rackspace in a managed data centre. Since then, the game has been rewritten into Unity and evolved to be able to support the mobile devices and as well as Steam, and has migrated from Rackspace to AWS. So why are we here today? The points that we're going to probably cover today are how we develop and release and support various features being developed at the same time, as well as being able to develop for a live game and add features as we go along. What our daily roles are and responsibilities of being both in a QA role as well as a DevOps role. The tools and resources we rely on to do our jobs. The challenges, we'll touch across a little bit of the challenges that we might face and how we overcome them, and hopefully to give a better understanding of what technologies and processes we use for this sort of service model.
Okay, so to cover everything that Karen just touched on then, we're going to run you through how sprints work for us at KIXEYE. So we develop and release content on a monthly sprint cycle, and then we plan for our downtime to be midweek so we can address anything that could possibly come up on like the Thursday or the Friday of that week. We used to actually have weekly sprints, but then we started producing larger features with so much extra content that we needed that extra time to be able to prepare and plan for that much work to be done. So we usually work on new content and new features every single month, but some features are actually larger and require either extra development or tech or research time, or sometimes our roadmap changes and people are shuffled and reprioritized, so certain features will be worked on for more than one sprint. We often develop our content behind flags so we can control the release schedule across all our 4 different platforms. Because we have different versions of the game active, we need to ensure we're not going to roll out something that breaks on iOS before we can get that submission process done. It also allows us to have a steady stream of new content throughout the month. So instead of giving you a bunch of stuff at the start of the month and then you wait an entire month to get something else, we can release it steadily throughout the entire time. And for us, we roll straight into the next sprint as soon as our downtime ends. So the cycle really is continuous for us continually. There's no point when we've finished working on the game and we have a product that we've shipped Even features have a version 2 where they're iterated on, which is usually in the sprint that follows that. So both all the work within a sprint and the work on features individually follows this cycle here. So it's planned out, it's developed, it's tested, and then we release it, and then the next sprint starts and we do it all over again. We're going to cover the steps within the cycle, which you can see here, and walk through the ones that relate to the DevOps and QA specific roles in the development cycle. So the light-coloured arrows at the final end of the cycle cover where QA kind of comes in overall. However, DevOps has a larger role earlier on in the planning process. And Karen will start walking us through this in more depth now.
Thanks, Bec. So, as Bec mentioned, these phases, the planning, defining, designing phases tend to start off towards the end of the previous sprint cycle. QA at this stage is minimally involved, but involved in the sense that they can start planning feature tests, test suites and stuff like that. While on a DevOps point of view, we're rarely in these phases from a game feature point of view unless there's major infrastructure changes. In parallel, we also have our DevOps features that we need to plan, define, design, launch, and so on and so forth. Our game architecture, in a generic sense, is shown up there. So what we consist of is, one, we're hosted in AWS, and we consume services such as the web services, being EC2, base and map and Galaxy services, which then back onto MongoDB databases, which store game data and galaxies and users. We've got battle and combat servers for peer-to-peer as well as peer-to-AI. We've got, because the game has multiple languages, it also has in-game chat translations. We do a lot of data analytics on both game data as well as system data, and that's supported by services such as Kafka, CDT, Snowflake. Being mobile as well as on web, we do push notifications as well as offers, and that's supported by Apple API and notification services. The infrastructure itself is backed by an underlying messaging service, and we've also got the databases mentioned such as MySQL for web and MongoDB for game. On the side, we also consume services such as S3 as well as CloudFront to allow us to present our assets globally, and also cache as well. So hopefully that gives a good idea. As well as the game architecture that I showed before, we also have infrastructure architecture to help support that. What I'm trying to depict here is the fact that as sprints roll, we have multiple features that are being developed in parallel. And these features need to be tested, work together with across multiple developers, and they require environments to be able to perform minimal integration testing and be able to make various changes and have it auto-triggered, deployed, and so on and so forth. So on the left there, you've got different feature sets being worked on. We also support load testing environments as well as your normal test stage and prod. From an infrastructure perspective, we also have monitoring infrastructure for central logging as well as log searching, indexing, and so on and so forth. We do build, deployment, release servers, instances. One of the things that we're looking at the moment or currently working through is actually service discovery and registration, and how to utilise that to inject data into your various services and processes. And we also have data analytics, as mentioned before, as well as source control and testing, that sort of stuff. Down in Brisbane, we also have build farms, because we build for different platforms. So these build farms consist of Windows and Linux and iOS builders, and they all have different processes to help that along. So working as a DevOps engineer at KIXEYE especially is quite a cross-skilled role, and the type of skills that we require need to be being able to design and architect different infrastructure, being able to design and architect redundancy and resiliency. We also need to have quite a fairly broad troubleshooting and problem-solving skills. We cover multi-languages, mainly Bash, Python, Ruby, but we also, as a result of having to support game architectures, we also need to be able to read or at least understand the general structures of the other languages, such as Java or PHP. Don't need to know it in depth, but at least be able to communicate with the rest of the developers. We also do networking and security, be able to know what the best practices are for that, not exposing unnecessary ports, what kind of intrusion prevention systems or scanning, how to do patches, that sort of stuff. We need to be very flexible. Things change really quickly, and also not being too resistant to change. So we need to embrace it quite a lot. So, in terms of the tools that we use, we have provisioning and building employ. So this at KIXEYE we use Ansible and Puppet to provide consistent environment setup. We use Bamboo for building and deploying game and environment configuration. We've got service discovery registration, which at this point in time is console, which is relatively new to us, and it allows service to register their current state and allow other service to poll whereabouts, say, a web or something else sits in your environment. We have monitoring and alerting, which is very important to us, and that consists of the Elasticsearch, Logstash, Kibana stack, as well as your graphical interfaces such as Grafana, Nagios, all that sort of stuff, as well as the important PagerDuty, which is what we use for on-call and alerting. As mentioned before, infrastructure and hosting is in AWS, and we utilise or integrate with a lot of third-party APIs, including AWS, but also the likes of Google, iOS, our own internal ones, and a whole other spectrums as well. So typically, when you develop new features, you've got multiple running in parallel, you need an environment, and these environments need to be relatively consistent so that when you roll them through your stack, you're not having some underlying changes that are going to cause you massive issues. So typically we have multiple environments being provisioned, and that's being provided by Ansible and Puppet. When we had our Civil Wars feature, which was a recent feature that we released, this was actually broken out into multiple sprints and also feature sets, and as a result we had multiple dev environments that brought these features up, and then they got merged together and we tested them all, and that also required environments such as load testing and play testing environments before going to test stage and prod. From a Ansible and Puppet point of view, diving a little bit further in, we utilise it for, as I mentioned, the environment consistency. There are differences between the two, but we use it as a coupled tool set. So a lot of people would either choose Ansible or Puppet, or even your other ones such as AWS CloudFormation or Chef or SaltStack and so on and so forth. At KIXEYE we use Ansible to provision the infrastructure itself up to an OS level, and we use Puppet to provide the actual OS and application above consistency. We use it for infrastructure as code to obviously document, have reusable modules and roles, and both of them have a really resilient and large open source community where even say like myself or anyone else who find bugs or features can contribute. There are differences between the two in terms of how you use them. So for example, you've got resources and tasks and how they're ordered for say Puppet, dependencies, and also the learning curve differences between the two. So to start off with, I'll touch on Ansible. So Ansible has reusable roles. It's a top-down language in the sense that you define a play and it pretty much runs from the top down through the bottom. So if you have dependencies, you write those dependencies in. If you need a file there, you make sure that the file is there first, and then you do your next thing, and then you do your next thing. The reusability of roles is really important because it allows you to define different types of environments while utilising the same basic skeleton structure. So there, for example, I'm showing how we've got a generic setup of an EC2 instance as well as a generic setup of AWS load balancers. We then interpolate environment-specific variables in to create your environment-specific infrastructure. So this is the playbook that I was mentioning. So the playbook then utilises the reusable roles that I showed before. So for example, running through an environment, you might launch, set up your initial Route 53 top-level domain, and then you might set up your security groups, then fire off your EC2 instances, whether that environment has 1 or 6 or whatever type thing, and then you keep going down the play. I haven't showed all of it, but it keeps going down, and you can notify, for example, HipChat or Slack or those kind of systems to let you know when it's failed or whether it's passed, sort of thing. So, in terms of Puppet, Puppet is very similar to Ansible, but Puppet has a slightly higher learning curve. The reason for that is Puppet is not a top-down run, so there are things such as dependencies which need to be thought through. So if you want a service to be provisioned onto an instance and you expect it to start, well, that service, the init file is not on the server yet, it's going to fail if you don't inherently put those dependencies on there, where it says, I want you to put the file on first and then do blah in your Puppet manifest. The Hira, so up here is a Hira example. So Hira is a add-on for Puppet which allows you to separate your data from your code. It supports multiple backends. We don't currently use any other ones except for the built-in Puppet backend at the moment, but it does support things like console, which, for example, if you wanted your config to be in your console key value store, you can actually plug Hira and Puppet into that backend and extract your environment variables out before the Puppet run. It allows you to define high-level workflows, separate your roles so that you might have a web role which then pulls in reusable classes or defined resources, and allows you to work through different exceptions, because we all have exceptions where you might have one environment has a slightly different look to another environment, even though you might have your standards, which are never standards, and you can sort of go, well, all right, I need to work through this, I've got a different scenario, and I don't want to import these classes into this role, even though that 99% of your environments have these classes for that same role. So up here I've shown that you can do that by doing, say, classes import for one environment and then reject a whole heap of ones for that same role, and then be able to import that in. So this is the classes and dependencies I was mentioning. So it's a very generic view of how you define, say, installing console, whether you put a group down and then user and then pop a file down, and then if you have a look at the file, it requires that the user and group actually be installed on that system first, otherwise it'll error. And that way it allows Puppet to, when it does its compilation of all the manifest, to go, cool, I'll make sure that I run user and group first before I set that file down. And then you can make sure, and then you can notify things like restart or reload a service. The top right-hand corner is just a general overview of a Puppet run, and then the bottom side is the same Hira views that we've got, where you can have different roles and environments and so on and so forth. From a building and deploying point of view, we use Bamboo for the majority of our stuff, and that allows us to pull in different streams and branches, and then build for cross-platform. So for a given build or a stream, we will have 3, 4, 5 stages, and those stages might be to build an Android APK or artifact, or an iOS, or the server files, or so on and so forth. The deployments then allow us to use different flags. So if you don't build a particular artifact, you can then utilise a flag to not deploy or not do something. Things that we're looking at for this at the moment for future endeavours is the ability to build generic artifacts that then allow us to inject environment-specific ones in. The reason why that's important for us is because when you build for specific environments, the build themselves can take a while. And if you've missed a dev environment of some sort because things change or you need to move your feature from one environment to another, that's another X amount of time that it will take to redo a whole new set of artifacts when nothing technically has changed other than the environment itself. And we're hoping to pull this sort of environment-specific config from a centralised area such as console or something else. Just an example of the Bamboo dashboard. So on the left there, it just shows that we've got not only multiple streams, but multiple platforms at any given time running through our Bamboo system. The stages up there, so as I said, we've got Android and iOS and server and so on and so forth. And it also allows our developers to, for their features, set auto triggers. So if something's changed within the Perforce or GitHub source code, you can set it to trigger so that it starts a build once an hour or something like that. So now I've mentioned some things that are, for example, Bamboo and some of the CI/CD tools that are relevant to our game, but may not be relevant to, say, starter projects or slightly generic projects. So something that I thought I'd put up there is just some alternatives if you're to look at, for example, AWS Code Deploy, which allows you to deploy app changes to existing, say, EC2 or S3 services. You've got Code Pipeline, which allows you to define your build, release, deploy flows and implement changes for code. Jenkins, if you have seen Jenkins actually brought out 2.0 about 4 days ago, and it's actually got some really cool pipeline features in. The difference between, say, Jenkins and Bamboo is Jenkins doesn't have, you don't have to pay for your slave licenses, so that can be a big, big plus. The UI could have to do with a little work, but hey, beggars can't be choosers, so. Elastic Beanstalk, so you can define and create your applications, your services, tie it with OpsWorks and create and deploy multi-tiered applications. And obviously you've got your different source code repositories. I'm sure you guys are well and truly aware of that, so with GitHub and Bitbucket or even AWS S3. So some of these to be aware of though is that if you were to go down that path, you will more than likely tie yourself to AWS specific services though, so that's just something to keep in mind. In terms of managing our game, we have multiple monitoring systems and it allows us, for example, this is a Grafana dashboard, or actually it's a combination of our Grafana dashboards. It allows us to pick up trends, figure out if something's gone majorly wrong due to a normal trending thing over 5 days, and all of a sudden you have big peaks or big drops, and that might be due to services going offline or marketing, for example. That might be a completely legitimate peak sort of thing. So that's very, very handy for us. On top of that, or actually underlying of that, we've got our central logging. So I've just depicted what a normal flow is. So we'll have FileBeat as an application on all of our instances, which picks up all the logs, syslog, application log, whatever log. and in specific formats, ship them off to Logstash, which processes them, indexes them, sends them to Elasticsearch, which stores them, allocates them out to different shards, especially when you get bigger and bigger. And then that allows us for either DevOps or developers or management to be able to search through Kibana. So if you want to search for some exceptions or search for particular users or application logs, we use Kibana for that. And if you want to view telemetry or metrics, that's where Grafana comes in handy. And I will now hand over to Bec.
Okay, obviously that was a lot of information Karen had to go over pretty quickly, so I just wanted to reiterate what Mara said earlier, that both the slides will be available online after this, so you can look at all the images that Karen did up for you, and also you can pick Karen's brain later in question time because she has a lot of knowledge about DevOps. Sorry. Okay, so that covered all the way from the top of that cycle we showed you earlier for the sprint, all to the building deploying stage. So now we'll go over testing. So the testing part of the cycle is more QA heavy than any of the other previous sections. So it looks like it comes near the end of the development cycle overall, which it does if you're looking at the sprint from a top-down way. But testing is effectively continuous for us in QA because of the amount of features on the go at once, and also because different departments start work on new content at different times based on what the feature's priority is on the roadmap. QA always has a feature or code improvement in testing at all times during the sprint. So QA start testing features and builds now because they should be ready for us to start trying to sign them off before the date we're planning to cut the RC rolls around. Devs also do some of their own testing, like unit and load testing, which Karen will touch on later as well. Some features, like the recently released Civil War that Karen mentioned, are large enough that company-wide playtests will be performed where everyone gets in and plays the game, so we can both get design feedback and also see what goes terribly wrong when 50 people are trying to interact with something at once. So we'll break down how testing works in QA now. So during the testing stage, we'll first work towards signing off all the features, and then we'll work towards making sure the build we're about to give to the public is solid. So each sprint currently contains around about 5 features, and a QA is assigned to each one. If it's a large feature, sometimes more than one person will be working on it. And the QA working on that will develop and run test plans and eventually say when that feature's signed off. So we always keep our features separate when they're being developed, so they can be tested in isolation and they don't block each other in any way. It also lets us keep our solid main build separate from any new changes until the time when they need to come back. Because of how many features we have at once and also how large some of the features are, 2 QA can be working on totally different features and not see the other one until everything's back in the main build. So when someone in QA is assigned a feature, there are 2 major ways they can approach setting up their testing. So if the feature is a smaller change, for example, if we're just allowing a certain piece of tech to be stored in an existing Office system, you can create a spreadsheet to cover all the changes, and that's fairly straightforward. But if the feature is more major, we have to go through a certain set of steps. First off, we'll create an acceptance criteria, which is a set of test cases based on the design that was specified earlier in the sprint. We'll then have these acceptance criteria signed off by the key developer of a feature, which is usually design or sometimes a gameplay engineer. Then we'll add all those test cases and the steps to reproduce them to a test suite in a Google spreadsheet, so that we go through and we say, this is how you should be able to get the step to occur, this is what should occur in the end, and then we'll import all those tests into our practice test system, which they can be then run through there. And the results of that suite and the resulting tickets that come out of it give an idea of how close the feature is from QA sign-off. So during the sign-off process, we also run as much ad hoc testing as we can. So this is testing that's outside of the more strict bounds that we write up in a test suite, but it mostly follows a normal user experience. We also perform negative testing during this time, which is probably the most fun kind of testing for QA. It's trying to use a feature in a way it was never designed to be used. So you can find out things like, does the game crash if you escape the login screen to the web, like during still being in the game and stuff like that. Throughout the whole testing process as well, we also do stand-ups, which allows us to keep up with smaller non-spec changes that are being made to improve the feature throughout its development. And this allows us to know what to check and if we should update our test suites or run certain tests again and maybe check new areas that might now be affected by a code improvement. Once an environment is free of major bugs, we give the sign-off for it and we bring it back into the mainstream with all the other signed-off features. So once things are now back in this mainstream, we cut an RC, which means we make a release candidate build which contains everything we need for that release. We're usually in the last week of the sprint by now, and as this is the first time we're testing all those new features back together, there are usually multiple RCs having to be built and deployed and tested because of all the new issues found when everything gets merged. So testing of the RC build involves another set of steps like testing a feature. So you'll have to test parts of the features again that might be more affected by interacting with new features. And we also have to do structured testing like fire and smoke tests. And fire and smoke tests are test suites which test all the major parts of the game like purchasing, loading, combat, relocation, anything that interacts with the server. We also run a mock downtime when we first push our build to stage, because stage is the environment most like live, and it's the final one that we put it on before we release it. And during this mock downtime, we run everything from whitelisting our users to make sure they can get through the canvas, and then we run fire tests when the game's in maintenance mode, and then see if you take it out of maintenance mode and everything's fine. So because we have to wait on Apple approval to be able to release the mobile platforms together, this means that the game version that's currently available on live will still be accessible for mobile users after we release. So for this reason, we have to run backwards compatibility tests on the RC that we've cut. And we run these for both individual features, and we run smoke tests through on that build as well to make sure it's solid in all the possibly affected areas. So because we do gate some features behind flags, only certain features do need to be focused on during this, which is a slight relief as we're usually really, really close to having to release now. We need to start wrapping up our testing if we can. For the same reason that we do test backwards compatibility, we also have to test bumping the minimum version. This test involves locking people out of old versions of the game and prompting them to update to the latest one, so that we can then release new features across the consistent version of the game, and we'll make sure that everyone's running on the same version and we'll see the same thing. So we also check the game flags for the new features, check that you can turn them off, and then turn them off in case you need to turn them off on live if something goes wrong. So at this point in the overall sprint cycle, QA will also start looking at the upcoming features that design have spec'd up for us. But for us overall, this is lower priority than trying to get a bug-free build out to the users. And now Mara will talk over some other testing we do.
Hello again. So Bec's just been through what we'll generally do for our feature tests. There are also some other tests that we do every single sprint, and those usually cover things like regression, marketing, or flag testing. With regression, it's usually when we have like a new version of Unity or a new plugin that's been added to the game. At this point, we have to go through and test every single feature in the game that's already existing. So that goes from account linking through to Civil Wars and stores and everything. The marketing tests are just when we receive new offers from our marketing team, and for those, it's pretty straightforward, but we just have to run them every time to make sure everything works correctly. Another thing we do every sprint is we go through and we reorganize Jira. With Jira, it's basically just verifying any tickets from the previous sprint or moving them to the next sprint if that's appropriate. So we've spoken about the processes that we do, and I just want to let you know a little more about the tools that we use. In QA, we'll use a few different systems and tools to test a feature, but primarily we'll switch between HockeyApp, Google Services, Practitest, the Admin Panel, and Jira, and occasionally we'll also use Facebook developer tools. So this is HockeyApp, and we use HockeyApp to download and install beta versions of the game onto our mobile devices. HockeyApp's great because it stores every single version that's deployed to it, which means that when we do our backwards compatibility test, it's really easy because we just have to go in and download an older version. This is great because we can make sure that the new features in the latest client build don't break on the old client. Another thing HockeyApp helps us with is getting crash logs. So if there are any game-breaking bugs in a build, the crash logs will be sent to HockeyApp. And this will always include the call stacks, the user IDs, and the devices the issues were seen on. This is great because then we can monitor the crash logs and close related tickets when they go to live. Google Docs is probably the biggest suite that we use on a regular basis. We use the docs for writing acceptance criteria and testing guides, and then we'll go over to Sheets where we'll use it for testing, planning, and tracking. A basic sheet with some data validation is the quickest way that we can collaboratively test, which is really important in our office because there are lots of different QA teams on different schedules. The good thing about this is we're able to track who is doing what at any given time, and that means that people can pick up where someone else has left off simply by looking at what they've marked as complete. Practitest we actually use pretty much as an extension of Google Sheets. Bec mentioned it earlier, but what we use that for is we'll write stuff up in Sheets and then we'll import it to Practitest, and we can run through the tests in a really visual way, mark things that are bugged and link them to it, so it's easier to see what features have what bugs linked to them. Next up is the admin panel, which is actually developed in Office at Brisbane. And there's one for every single environment that we work on. This is a really great thing that we use. And it's how we change flags, we set up our game versions, we change our release notes, we edit users, and it's also how we set up any schedulable event in the game. So anytime you see an event or a civil war, that's all set up through the admin panel. We also use Jira very frequently. Jira is obviously how we track and it's how we ticket our issues. And we use it pretty differently to how developers use it. So devs use it to track what tasks they have in any given sprint, but we'll use it to we'll use it to bug new issues, track and verify them, and we'll also use it as a database for all the existing issues. This way we can see who is assigned to what feature and who to talk to about whatever issues we encounter. It's a great way to see what a feature is made up of and all the testable elements within it. So for instance, if a new feature has specifically a new UI element to it, that will be ticketed and linked to the feature, so we can just see it and know exactly what we need to test and when. Finally, we use the Facebook developer tools pretty briefly. These will only be updated occasionally, but it's actually really crucial because it's what we use to whitelist access and purchasing on the Facebook platform. It's also used to create test users for our external teams, who I'm going to talk about more now. We have two lots of external teams at KIXEYE, and that is localization and the general testing teams. So first up, I'll talk localization, and for that we have two groups. We use Bridgeway for translating all of the strings in-game, and that includes marketing. They translate it into 11 languages and then upload it to something called Transifex. The enzyme testers now come in, and they're quality assurance testers. They go in and they'll test all of those strings on Transifex to make sure that they're all grammatically correct and they all fit with the theme of the game. And then they'll check those strings again in-game to make sure that it hasn't broken any UI and it all makes sense. Next up we have our general testing teams, and that is Amber in Romania and Digital Hearts in America. These guys are great because they allow us to get through far more testing than we're able to do on our own in the office. It also means that we get more coverage with overnight testing from Amber in Romania and testing on the weekend from Digital Hearts. This is all just because of the time differences between us and them. It's great to have these guys because it gives us more eyes on a feature, which is always really helpful because no matter what you're testing, there's always going to be some weird edge case that you won't see until the last possible moment. And having these guys along with us helps us identify those a little more early. Finally, I'm going to go through the release process. Bec did that a little bit earlier on, but just going to step you through it. So when we're going to release a game, we have the RC ready to go. The canvas is locked, and this means that players can't enter the game anymore. At this point, the game is taken down and the new build is deployed. This is when the DevOps or the back-end engineers will come in and they'll make any necessary updates. When we're given the okay, we'll go in and we'll do fire tests, which is payments, logins, combat, relocation, chat, all the really critical areas of the game that get used probably the most frequently by players. At this point, we'll also run tests for any new features that are being deployed at the same time. So this might be running a new event and making sure that the fleets all display correctly. After this, the canvas is unlocked and the players come back in. Once this is done, we'll also run smoke tests, which are very similar to the fire tests, but far more expansive. We'll go through the same areas again, but we'll test every single area in the game. So that's researching, combat, tutorials, building, base management, just like everything. We also have some post-release testing that we go through every sprint as well. Actually, the first one I'm going to talk about isn't every single sprint, but it does happen, and when it happens, it can be a bit of a pain. Generally, the thing with online games is things can go wrong, but the beauty of them going wrong is we're able to fix them in a really quick amount of time, most of the time. So when we have issues, often we won't actually see them in the QA side because there's 6 of us on an environment at any given time. And sometimes you might have multiple devices because we do use about 20 different devices in the office, but it's still only going to be around 30 people in an environment at any given time. And then when you go to live, there's substantially more players than that. So they can encounter issues that we wouldn't even dream of seeing. So when there are issues in this light, we'll usually get a message from customer service or our community managers, and they'll let us know what's going on and what needs to be fixed. At this point is when we'll consider doing a hotfix. And hotfix are pretty stressful. They're effectively just a very condensed version of a release. So for them, we'll run all the same tests prior, so all the smoke tests and stuff, and there'll be two different kinds of hotfixes that we'll do, one client or one server, depending on what kind of issue it is. If it's a client hotfix, we'll have to take the game down and do everything during downtime again, which is not desirable. We also do server hotfixes, and those can be deployed directly onto the live game, which means we don't have to take it down for testing. After these, we also do min version bump tests, as Bec mentioned. That's just making sure that the players are effectively forced to update their game if they're playing on mobile. The reason that we do this is every new feature that we release is hidden, but once we have it up there, we want people to update to the new version so that eventually we're able to turn those features on. If we don't bump the version, people can be playing on a build from months ago, and then if we put a new feature on, it'll completely break everything for them. Once the minimum version is bumped, that's when we'll turn the game flags on. And that's it for me. I'm going to hand back over to Karen to finish up.
Thank you, Mara. Just to wrap up the testing, we've also got developed style testing, for example, game code testing, and that might include load testing utilising test bots, where we run up your features in one specific environment and then run up another environment called test bots, which allows us to load a hell of a lot more mock users against your features, and that allows us to, one, do performance testing, but also to see how the features itself reacts. We've got a little bit of automated code tests, which is relatively new for us, and that allows us to just quickly run through the game and make sure the core features are working. In terms of unit tests, it's relatively new and also minimum, and that's due to how the game started, also the cultural reasons around that. From a DevOps testing point of view, we run our stuff through the lower environments. We don't often need to run our own environment to test our stuff, because a lot of the time we can run it on existing feature environments. Our unit tests are also minimal, but they're also on the roadmap. So. In terms of our game platform, so we touched a little bit about our game platform, so iOS and Google and Facebook, Steam, KIXEYE.com, as well as the WebGL, which is in progress. Now, being cross-platform, there can be problems or challenges that arise as a result of publishing to so many of them. One of the examples is that iOS has a pretty long, tedious release process and approval process. And as a result, if you're trying to release new features, you sort of have to hold it back across most of your platforms and wait for iOS to be approved before you can bump everything up. So flags, in that sense, for us is really important to be able to at least deploy most of our stuff and hold them back until something has actually been approved. And then you can release iOS as well as your Android packages. In terms of updates for web and Steam, they're pretty immediate. Straight after downtime. And that's us for today. So thank you very much for sitting there, hopefully interested. And if you have any questions, feel free to ask any of us. Any of us.